Hello everyone, this is Shanko and welcome to chapter 1 of the Spring tutorial for beginners. So in this chapter we're going to see some of the problems with the legacy Java applications that do not use any framework and why we need a framework in the first place. And yeah, let's look at some of the problems with the existing legacy Java applications that do not use any framework. So the first point is boilerplate code. Now what is boilerplate code? Boilerplate code is some piece of code that you need to write again and again in all your applications without changing them. So the world is moving towards a direction where the application developers spend most of their time developing and focusing on the business logic and not having to focus on boilerplate code such as connecting to database or reading properties from a property file and stuff like that. So as application developers, we want to spend more of our time trying to develop or trying to address the need of our business and try to implement the business logic rather than having to write boilerplate code, right? So most of you must have seen or might have seen this kind of a code to connect to database at some point of time in your career. So as a beginner, you might be fascinated by this kind of a code, and you might feel like you have achieved a lot trying to connect to database from your Java application to this kind of code. But over time, as you gain experience, you would realize that this is much of a headache, and this is really a headache, trying to connect to database every time and having to write this kind of code while trying to connect to database. So you would want a way where you can avoid having to write this kind of a code. So that is a very important reason why we need a framework, so that we can reduce boilerplate code as much as possible. And next point is object creation and maintenance. Now suppose we have these classes in our application: class A, class B, class C, D and E, right? And class A is being used by class B and class E, and then again class B is being used by class D, class C is being used by class A, and class E uses class A, right? So one way we can do this is if we need to introduce, or if we need the functionality of one class in some other class, one way we can do it is by creating an object of the other class, right? But the problem with creating object is every time we create an object of a class, it consumes some space in the memory, and that is not something we would want as application developers, because that reduces the performance of our application. And again, once we create an object, there's a life cycle that surrounds or that revolves around that object, or rather an object has a life cycle for itself. So once the object is no longer being used in the application, it is collected by the garbage collector and it is destroyed. So if we are creating objects ourselves, we would need to maintain them, we need to maintain their life cycle, and we need to make sure that they're removed once there's no reference of that particular object in the application. And that again is boilerplate code, and again we need to write a lot of code to make sure that the objects are being maintained properly. So that is again a big challenge with our Java applications. What is the next challenge? The next challenge is tight coupling of business logic and cross-cutting concerns such as logging, exception handling, and so on. So we'd want our applications to be as loosely coupled as possible. And why so? So that the modules are independent of each other. Right now, what are cross-cutting concerns? There are certain functionalities which we need throughout our application, in all the components of our application, and these are stuff like logging, exception handling, security, and so on, right? So most of the legacy applications have everything in one place. You would find the user interface, the database access layer, everything inside one project, and that becomes a really big project, and it becomes really difficult to maintain that kind of a project. So that is again a big challenge with our legacy applications, right? And the next challenge is reading values from an external property file. So in our application, when we are building an application, we would want we want to run it on different environments, and in all companies or all organizations, you would have your application running on different environments such as development environment, testing environment, and so on, production environment, pre-prod environment, and so on, right? So for each environment, you would have different configurations, or different properties. Maybe the database configurations would be different for different environments, and so on. So having to read properties from an external file or an external source again becomes a headache in our legacy Java applications. And we have to write boilerplate code every time we want to read properties from a properties file in our legacy Java application, right? And then most often than not, our applications are web-based applications where we have a front end or a user interface that we need to render, or maybe our application serves as an API which is being consumed by a client. So creating such applications need a lot of coding, where we would need to maintain code for servlet, we need to maintain code for controller, we need to maintain code for the dispatcher, and such other stuff. And again, most of the applications are connected to a backend database, and again for each backend we need to create the DAO layer, the data access object layer, the service layer, and stuff like that, and so on. And then again we have to create the connectivity, we have to write code for connecting to the database using JDBC and other stuff. So there's a lot of coding that goes on. There's a lot of coding that is required while trying to create a web application, right? And again, this is not a part of our business logic. Our business logic is completely out of scope here. We are just trying to deal with the flow from our front end to the back end, and again from the back end to the front end, right? So for that we'd have to write a lot of code which is not a part of our business logic. So that becomes a headache and a challenge for developers. And then the sixth point is taking care of best practices. So now when we are building an application, we would want to make it maintainable, we would want to make it scalable, and we'd want it to be very easily understandable by other developers who are working on the same project or who would be joining the team in the future. So there are a few best practices that we need to take care of while creating applications, such as modularity, loose coupling of components, and so on. And with our existing Java applications or with our existing legacy applications, it becomes really difficult to maintain standards and maintain best practices throughout the application and in all our applications. It really becomes difficult. And the next point is taking care of security needs of an application. So most often than not, we would have to create applications which are web-based applications, where we have screens, where we have user interfaces, or where we have URLs that are being exposed. And now when a user is trying to access a resource or trying to access a page, trying to access a user interface, that user has to be an authentic user, and that user has to be authorized, right, to use that resource. So first, a user authenticates herself or himself by logging in to the application using maybe a username and password. And once the user is authenticated and she or he is trying to access a resource, that person has to be authorized, or that person has to have the authority to access that particular resource that she or he is trying to access, right? So these are the security concerns that comes along with our application. So that has to be taken care of. And in a Java application, in a legacy Java application that doesn't use a framework, it becomes really difficult to take care of these kind of security needs. So these are some of the points, or these are some of the concerns, or these are some of the problems with our legacy Java applications which do not use frameworks. And that is the reason we need frameworks such as Spring, which addresses these kind of problems. And in the next chapter, we are going to see how Spring addresses these problems and what Spring is all about. So I hope you like this video, and if you did like it, please give it a thumbs up and stay tuned for chapter 2. Thanks for watching.